Greetings. In this video, I'd like to show you how to solve some problems where you're asked to figure the probability of a particular score. You've already learned the basics about using the normal curve to compute probabilities given a specific z-score, and also how given a probability value to determine the associated z-score. Most textbooks, yours included, have you using z-tables to figure these kinds of problems out. But this is the 21st century, and I don't think that there's any need to go to a table. Instead, we'll be using an app, which is much easier to use once you learn how to use it, and it's available on both Android and iOS. Okay, let's dive right in and get started. Okay, so here's the problem from the text. In parts A and B, you're asked to determine the percentage of people that consume various amounts of sugar. We'll get to part C in a minute. The problem gives you the overall mean sugar consumption as well as the standard deviation of sugar consumption. Okay, so we're going to begin every problem we do the same way. Write down the key values given in the problem. That's step one. Step two, and this is absolutely critical, make a diagram showing what the problem is asking. As you can see in part A, you're being asked the percentage of people who consume more than 32 teaspoons. That's a heck of a lot of sugar, by the way. So I put a 32 on the graph, and since we need the percentage of people who consume more than 32 teaspoons, I shade the area under the curve to the right of 32. Okay, now I've set up the problem, and all I need to do is open our calculator app to solve it. Before we do that, let me just say that if you were to use the z-tables, the book calls these unit normal tables, in order to, I think, confuse you further, we'd have to convert these values to z-scores. But using the app, this part is unnecessary. Okay, so here's a view of the screen from the app. A couple of things to pay attention to here. You'll see, first of all, that in the distribution area, I've selected normal. This is critical. We may be using other distributions later in the term, but right now, we're going to stick with normal. We're going to type in the mean from the problem, that's 22.7 right here. Then we're going to type in the standard deviation given in the problem, 4.5. And then, this is critical, you're going to click that next drop-down box and make sure for this problem that you have upper tail selected. What you need to do is you need to verify that the diagram drawn by the application is shading a similar area to the diagram that you drew. This is why it's so important to draw that diagram out. Okay, then you'll enter 32, which is the question that the problem is asking you about. You'll fill in 32, hit enter, and there's your solution given right there. Okay, once again, let's start off with a clean slate now and tackle part C. Part C is actually a little bit different because in part C, we're not given a value, we're not given a score, as it were, we're not given a number of teaspoons of sugar. We're asked instead to find out the correct number of teaspoons that corresponds to the top 5% of the population. So the process is really very similar. Again, as always, we're going to draw our normal distribution. Oh, that's my best curve of the day so far. And we'll label it correctly, 22.7. And now we'll put a line. We'll indicate that this is the 5% area, the 0.05 area, and we are looking for that value over there. What is that value? Well, we can use a calculator the same way we did before. And you can see what I've done. Again, distribution is still normal, and these values are the same. But this time, instead of entering a probability value here, we're going to, instead of entering a score value over here, a number of teaspoons, we're going to instead enter the percentage we're looking for over here. So 5% is 0.05, and this gives us the correct value. So what we're saying here is that 5% of the population consumes more than 30 teaspoons of sugar per day. Okay, let's look at a few more problems, or a few more problems with this same data set. Part B asked for the number of people who consumed more than 18 teaspoons of sugar per day. Suppose we were interested in the percentage of people who consumed less than 18 teaspoons of sugar. Well, again, we'd start off by drawing our diagram, which I've done right here. Okay, and we'll label it appropriately as we've been doing. But now we're interested, we'll just put 18 over here. Doesn't matter exactly where we put it, as long as it's not crazy. Now we're interested in the number of people, in the percentage of people, I should say, that consumed less than 18. So we're going to solve the problem in a very similar way. I'm going to paste in over here what the calculator returned to me when I just ran it. Here we go. And you'll see we've got the same normal distribution, the same 22.7, the same 4.5 of the standard deviation, but this time we've selected this drop-down box so it shows the lower tail. It's very important. And then we proceed as usual. We just enter that 18 value because we're interested in the percentage of people that consumed less than 18 teaspoons. And there's our answer. About 14.81% of the population consumes less than 18 teaspoons of sugar per day. Okay, now we'll take a look at another variation. I'll start off by erasing what we have here so far. And now we'll look for the percentage of people. I keep saying number, I'm sorry about that. The percentage of people who consume between 18 teaspoons and 32 teaspoons per day. And the process is very similar. Again, always draw that diagram out. Oh, I should get an award for that bell-shaped curve. That's a beauty. We'll label it appropriately, 22.7. And now we're interested in the number of people between 18 and 32. Now let me put the 32 a little further out so it looks remotely to scale. It doesn't have to be to scale. Now we're interested in what that percentage is. Okay, we're interested in what that percentage is. And again, we'll go to the calculator. I'll paste in the value I have. There we go. And what do you see? This time, still normal, still the same mean, but this time we've selected middle as the option. And you can see that the diagram the calculator draws is similar to the one that you've already drawn, and that means you've set the problem up correctly. That's really where students have problems with this thing, is setting up the problem correctly. And that's why we draw the diagram. Okay, so we've entered 18, and we're going to say that the probability of this event, or the percentage of people, doesn't matter, the same thing for our purposes here. The probability that someone is between 18 and 32 is 83.25%. Okay, and there's just one more version of this. So we'll set that up. So I've cleaned up our space here. And if you played with the calculator at all, you can see there's one other option. And that's the percentage of folks who are either less than 18 or greater than 32. Well, those are the numbers we'll use. And it's almost time to quit because my normal curves are starting to look not that great. So again, 22.7, and we're interested in the quantities in the two tails of the distribution, the two tails. So we want to know what's the probability that you are either in this group here on the left, the less than 18 group, less than 18 teaspoons group, or the greater than 32 teaspoons group. And as you can imagine, we're just going to change a setting in the calculator. I'll paste it in there for you. There it is. And again, set it the same way, but this time we've indicated both tails. We've asked it for both tails, and we've entered 18, 18, 32, 32, and this is the percentage of people who are either consuming less than 18 teaspoons of sugar per day, or more than 20 teaspoons, or more than 32 teaspoons of sugar per day. That's pretty much it. Of course, we could also give it a probability, and then ask for the values that delimit that probability in either the middle case or this both tails case. And I'll leave it to you to see how to do that. It's pretty straightforward. Okay, I hope that explains it all to you, and you'll be good to go.